Welcome, everyone. Get ready, because today we're taking a deep dive into the world of quantum physics.
Yeah, we're talking about some seriously mind-bending stuff.
We're going to be talking about teleportation,
Consciousness.
the nature of reality.
Yeah,
And
get this.
we're not just theorizing,
Right.
we're diving into some cutting-edge research.
We've got articles.
Wikipedia deep dives.
And even an interview with a leading scientist in the field.
Stuart Hameroff.
What's so cool is that these concepts that used to be pure science fiction,
Yeah.
they're moving closer and closer to real-world applications.
It's wild, like this news from EcoPortal.
Oh, yeah.
Scientists have actually teleported quantum information
Wow.
between two different quantum computers
No way.
for the first time ever.
That's huge.
And they shattered the previous distance record.
Okay, but hold on.
Yeah.
We need to be clear about what quantum teleportation actually is.
Right.
It's not like beaming people around like in Star Trek.
Okay.
It's about transferring quantum information.
I see.
Using this principle called entanglement.
Entanglement, that's where two particles are linked, right?
Exactly.
And they instantly affect each other no matter how far apart they are.
It's like they're connected by some invisible force.
Spooky action at a distance, right?
Exactly. You got it.
So how does this apply to quantum computers?
Well, quantum computers use these things called qubits.
Instead of bits.
Yeah, and qubits can be both 0 and 1 at the same time.
Whoa.
It's called superposition.
Okay, I'm following.
And entanglement allows us to link these qubits.
I see.
And that's how we can teleport quantum information between them.
Okay, so EcoPortal lays out some pretty big implications.
Oh, yeah, huge.
Building larger, more powerful quantum computers
Absolutely.
by linking smaller modules together.
Imagine that.
A quantum internet.
Unhackable communication.
And even using this to reorganize quantum networks to explore fundamental physics.
It's really mind-blowing stuff.
Okay, but I'm sure there are still challenges, right?
Oh, definitely.
Like,
well, keeping those entangled qubits stable over long distances.
That's tough.
And then integrating this tech with what we already have.
it's like trying to fit a square peg in a round hole.
Okay, so we can teleport information.
Right.
But what about consciousness?
Ooh, good question.
Is that even possible?
Well, that's where the Orch OR theory comes in.
Okay, I've heard of that.
It was proposed by this physicist, Roger Penrose,
Okay.
and our interviewee, Stuart Hameroff.
Right, the anesthesiologist.
That's exact.
So they think consciousness starts at the quantum level.
Yeah, specifically within these tiny structures called
And
microtubules.
inside our neurons.
Yeah, you got
So
it.
instead of our brains being like regular computers,
Right.
they're saying it's more like a quantum computer.
Exactly.
Okay, so Penrose argues that consciousness isn't just a byproduct of all this computation in our brains,
Yeah,
but that it's like a fundamental part of the universe.
right.
And it stems from these quantum events happening in our brains.
That's the idea.
Yeah.
Okay, but where does this Gödel's incompleteness theorem come in?
So Gödel's theorem shows that any system of logic,
Mm-hmm.
it'll always have limits.
Okay.
And Penrose uses this to argue that consciousness,
Yeah?
because it's so complex and nuanced,
Yeah.
it can't be purely computational.
So it must involve something beyond just algorithms.
Right, say.
Something non-computable.
Right?
And he thinks this non-computable element is linked to quantum processes.
Precisely.
Whoa.
Penrose believes that these quantum events,
Yeah.
specifically something called objective reduction,
Okay.
they're the key to understanding consciousness.
Okay, I'm trying to keep up.
No worries.
So that's where Hameroff comes in with his research on microtubules.
Yes. Hameroff believes that microtubules, with their unique structure and properties,
Yeah.
are the perfect place for these quantum events to happen.
It's fascinating that he got into this through anesthesiology.
I know,
He talked in the interview about how he was obsessed with microtubules back in med school. And that led him to anesthesiology so he could study consciousness.
It's amazing how things connect.
And his perspective as an anesthesiologist is so unique.
It really is.
Like, he sees anesthesia as this big clue to how consciousness works.
It's so interesting how a gas can just knock you out,
I know, right?
but most of your brain functions are still going.
It does make you wonder if consciousness is a separate thing,
Yeah, maybe a distinct process.
potentially linked to these quantum events in microtubules.
That's the idea.
And Hameroff's not just theorizing.
No.
He's doing experiments.
He is. He's using lasers to stimulate microtubules.
Wow.
And he's found evidence that anesthetics can mess with those quantum effects.
That's wild.
And get this, he's got this new study with rats
Oh, yeah.
showing a link between microtubules and how long it takes for anesthesia to kick in.
That's incredible.
And he's doing even more research in India.
What's he doing there?
He's using EEG to measure brain activity under anesthesia.
Oh, wow.
He thinks this will prove that anesthesia affects microtubules
Wow, so much going on.
and that they're crucial for consciousness.
But I know there are scientists who aren't convinced by the Orch OR theory.
Yeah, there's always skepticism.
They say the brain's too chaotic for those delicate quantum processes.
They call it warm, wet, and noisy.
Right. Like, how could those quantum effects last in that kind of environment?
It's a valid point.
It's hard enough to control them in a lab.
Exactly.
So Hameroff has to have some pretty good counter-arguments.
Oh, he does.
Like what?
Well, he says that water molecules, which people usually think cause decoherence,
Yeah.
he thinks they might actually help stabilize the microtubules.
So the water could be protecting those quantum processes.
It's possible.
That's fascinating.
And he points to the structure of the microtubules themselves.
Oh, yeah.
Their repeating patterns, their helical pathways.
Uh-huh.
He thinks it could be correcting those quantum errors.
Like a built-in defense mechanism.
Yeah, kinda.
So the microtubules themselves are shielding these quantum effects.
That's the idea.
Wow, that's amazing.
And then he brings in gap junctions.
What are those?
They're these tiny channels that connect neighboring cells.
Okay.
He thinks they might be facilitating this long-range entanglement throughout the brain.
So instead of each neuron being isolated,
Yeah.
it's more like a giant network connected at the quantum level.
Exactly.
That completely changes how we think about the brain.
It's a pretty radical shift.
I need a minute to process all of this.
It's a lot to take in.
So before we dive even deeper into the quantum rabbit hole,
Okay.
let's talk about something a bit more tangible.
Sounds good.
This experiment that achieved a world record for quantum entanglement
Oh, yeah.
using optical fibers.
That was groundbreaking.
This research from the Austrian Academy of Sciences.
They're pushing the boundaries of quantum communication.
So this is where entangled photons come in, right?
Exactly. Particles of light.
And they entangle these photons over a massive distance
248 kilometers.
using optical fiber.
More than double the previous record.
That's mind-blowing. What does this mean for the future of quantum communication?
This is a huge step towards a real quantum internet.
Whoa.
Imagine a network where information is transmitted instantly, securely,
Yeah.
with practically zero chance of anyone eavesdropping.
That's amazing.
It could revolutionize everything.
Okay, but how does this correlated randomness, as they call it,
Right.
actually translate into unbreakable encryption?
Imagine we each have one of those entangled coins.
Okay.
We flip them at the same time.
Uh-huh.
We get the same result, even if we're miles apart.
Yeah.
That shared randomness becomes our secret code.
I see.
Anyone trying to intercept those photons would mess up their entanglement.
So it's like a built-in alarm system.
Exactly.
But I'm sure there are still challenges with this technology.
Oh, absolutely.
Like what?
Well, preventing those photons from getting lost over those long distances.
Yeah, that makes sense.
Quantum states are fragile.
Right.
They can easily get corrupted.
So how did they manage to entangle photons over such a huge distance?
They developed this special photon source.
Uh-huh.
It produces entangled pairs super fast,
Okay.
and they came up with a way to stabilize the signal,
I see.
so it's not affected by temperature changes in the fiber.
That's really clever.
It's like they're taming quantum mechanics.
Wow, so impressive.
It shows how much we're learning about the quantum realm.
It's amazing.
And who knows what other incredible applications we'll discover.
These advancements are exciting.
They are.
But they also raise some ethical concerns, don't they?
Oh, absolutely. We can't ignore that.
As this technology gets more advanced,
Yeah.
we need to think about the potential for misuse.
Right.
We need to make sure quantum technology is developed and used responsibly.
It's crucial.
So it's not just about the science.
Yeah.
It's about the ethics and values that guide its application.
Exactly.
Quantum tech has the potential to change the world for the better.
It does.
But we need to be mindful of the risks.
And steer it towards positive outcomes.
Well, we've covered a lot today.
We have
Quantum teleportation,
unhackable communication.
the possibility of consciousness
Yeah.
arising from quantum events in our brains.
Pretty mind-blowing stuff.
So where do we go from here?
Let's dive a bit deeper into some of the criticisms of the Orch OR theory.
Okay, you mentioned the warm, wet, and noisy brain argument.
Right, where people say the brain is too chaotic for those delicate quantum processes.
Yeah, if scientists struggle to control these effects in a lab,
Exactly.
how could they possibly last in the complex environment of the brain?
It's a valid point.
It seems like a clash between two worlds, quantum and classical.
It does.
So how does Hameroff respond to those concerns?
Well, he has some compelling counter-arguments.
Like what?
For example, He suggests that water molecules, which are often seen as a problem for quantum coherence,
No.
might actually play a role in organizing and stabilizing those microtubules.
Oh, interesting.
So they could be creating a protected environment for those quantum processes.
So the very thing some scientists see as a hindrance
Yeah.
could actually be part of the solution.
It's an intriguing possibility.
That's a cool quiz.
He also proposes that the specific structure of microtubules,
Okay.
those repeating patterns, the helical pathways,
Yeah.
might act as a sort of quantum error correction mechanism,
Oh, wow.
allowing those fragile quantum states to survive.
So the microtubules themselves are protecting those quantum effects.
That's the idea.
Wow, it's amazing.
And he also points to the role of gap junctions,
What are those again?
those tiny channels that connect neighboring cells.
Right? Right.
He thinks they could help facilitate long-range entanglement across the brain.
So we're not looking at individual neurons,
No?
but a massive network linked at the quantum level.
Exactly.
That's a huge shift in perspective.
It really is.
It changes everything.
It does.
But are there any experiments to support these claims?
There have been some intriguing studies,
Okay.
but this is still early-stage research.
So there's more to come.
Definitely.
Hameroff himself is doing research using EEG to measure those high-frequency brain activities.
Yeah, that megahertz activity.
Hoping to find concrete evidence for the role of microtubules and quantum effects in consciousness.
It's exciting stuff.
So the debate continues.
It does.
Quantum versus classical.
Microtubules versus neurons.
It's like a scientific showdown.
It is.
But what does all this mean for us?
That's the big question.
What does it mean for how we understand ourselves in the universe?
If consciousness is a quantum phenomenon,
Yeah.
it changes everything.
It makes you rethink things like free will,
The nature of reality.
our place in the cosmos. It's
Absolutely.
like we're on the verge of a scientific revolution,
A paradigm shift.
one that could completely transform how we see ourselves.
It's not just about science either.
Right.
It touches on deep philosophical questions.
About existence.
The mind-body problem.
Even the possibility of life after death.
It's a lot to ponder.
This deep dive has been an incredible journey through the quantum realm.
It really has.
The lines between science and science fiction are blurring,
They are.
and the very nature of reality is up for debate.
It's mind-blowing.
And we've only scratched the surface.
There's so much more to uncover.
So much more to explore.
The quantum realm is full of mysteries.
Before we venture any further,
Yeah.
let's take a moment to recap what we've learned so far.
Okay.
We started with quantum teleportation,
Right? Transferring information between those quantum computers.
a feat that opens up incredible possibilities.
Secure communication.
Advanced computing.
It's a game changer.
Then we explored the Orch OR theory.
The idea that consciousness might arise from quantum events happening inside those microtubules in our brains.
We talked about the arguments for and against it.
And the ongoing research that could help settle the debate.
And finally, we discussed that groundbreaking experiment
The one that set a world record for quantum entanglement,
using optical fibers.
bringing us closer to a real quantum internet.
This deep dive has been a whirlwind tour through the quantum realm,
It has.
where science and science fiction collide.
And the nature of reality itself is questioned.
But before we go any further down this rabbit hole,
Yeah.
let's take a short break
Okay.
to let all this information sink in.
It's a lot to process.
We'll be back soon to continue our quantum adventure.
Get wait.
Stay tuned. Okay, so before we went off on that tangent, we were talking about the debate around the Orch OR theory.
Right. Some people are all in on quantum processes being essential for consciousness.
And others are like, hold on, not so fast.
Exactly. The warm, wet, and noisy brain argument.
It does make you wonder.
Right.
Are there any other examples of quantum effects happening in living things?
You know, there are.
Oh, really?
Yeah, quantum biology is actually a really hot field right now.
I had no idea.
Researchers are finding evidence of quantum phenomena all over the place.
Like where?
Well, one of the coolest examples is photosynthesis.
You mean how plants use sunlight to make energy?
That's the one. And there's more and more evidence that quantum coherence is key to how efficient that process is.
So plants might be using quantum mechanics to power themselves.
It's pretty wild, right?
Incredible.
And there's also evidence of quantum tunneling happening in enzymes.
Okay, remind me what quantum tunneling is again?
It's where particles can pass through barriers that they shouldn't be able to.
Oh, right, like going through walls.
Sort of.
Okay.
And this could be a big deal for developing new drugs.
I see.
So it's not just in physics labs.
Right.
Quantum mechanics is woven into the fabric of life.
That's amazing.
And as we learn more about quantum biology,
Yeah.
we might discover even more ways that these quantum phenomena contribute to life on Earth.
This whole quantum journey has been mind-blowing.
It is pretty wild.
But something I keep thinking about is if these quantum effects are so fundamental, why didn't we notice them sooner?
Good question.
You know, quantum mechanics has been around for over 100 years.
It has, but the reason we didn't see these effects earlier is mostly about scale.
Okay.
Quantum phenomena are really subtle, and they're hard to see in the everyday world.
Right, because we're so much bigger.
Exactly.
It's only when you look at things at the atomic level
Or even smaller, the subatomic level.
that these quantum effects become clear,
Yeah, it's like we've been living in a classical world.
oblivious to this hidden quantum world.
Right, this quantum symphony playing beneath the surface.
But now, with all our fancy technology, we can finally see it.
We've got these tools that let us explore the quantum realm with amazing precision.
And we're realizing that quantum mechanics isn't just theoretical.
No.
It's real.
It's fundamental to how reality works.
From how atoms behave to maybe even our own minds.
It's like we've discovered a hidden dimension.
A parallel universe with totally different rules.
Exactly, and the more we learn,
Yeah.
the more we realize how much we still don't know.
It's like an endless journey of exploration and discovery.
It really is.
Okay, let's bring this back to Orch OR for a minute.
Sure.
I know we talked about the skepticism about quantum effects in the brain,
Yeah, not everyone's convinced.
but Hameroff's really passionate about this research.
He is. He's dedicated.
What kind of experiments is he doing to support his theory?
Well, he's exploring a few different things.
Like what?
One area is his research using lasers to stimulate microtubules.
Okay.
He's seen that anesthetics can interfere with these quantum effects.
Really?
Yeah, which kind of strengthens that connection between microtubules and consciousness.
That's pretty cool.
And he's really excited about the study he did with rats.
What did he find?
He found a correlation between microtubules and how long it takes for anesthesia to work.
Oh, wow.
He thinks this is a big step towards proving his theory.
So he's really pushing the boundaries here.
He is. He's also doing research in India,
I remember him talking about that.
using EEG to measure brain activity under anesthesia.
Right.
He's confident that this research will provide the evidence he needs.
To show that anesthesia affects microtubules.
And that they're essential for consciousness.
This is groundbreaking stuff.
It is, and it's just the beginning.
There's so much more to discover about the brain and consciousness.
Absolutely.
You know, we touched on the ethical considerations of all this quantum technology,
Yeah, it's important to talk about that.
but I think it deserves a bit more attention.
You're right, with such groundbreaking potential.
It seems crucial to address those ethical implications.
Absolutely. As we learn more about quantum mechanics, we have to think carefully about how these technologies could be used.
What kind of concerns are we talking about?
Well, one big one is the impact of quantum computing on data security.
Okay, how so?
Quantum computers could break the encryption we use today.
Oh, wow.
That could have huge consequences for everything from personal data to national security.
So the same technology that could enable secure communication through the quantum internet
Right.
could also undermine our current security measures.
Exactly. It's kind of a double-edged sword.
That's a bit of a paradox.
It is, and it highlights the need for new encryption methods.
Ones that can withstand the power of quantum computers.
Exactly. Quantum-resistant encryption.
What other ethical considerations should we be thinking about?
Well, we also need to be aware of the potential for bias
Bias.
in the development and use of these quantum technologies.
Oh,
As with any powerful technology,
Uh-huh.
we have to make sure it benefits everyone.
Not just a select few.
Exactly. Equity is crucial.
These advancements should be used to address global challenges,
Absolutely.
to promote a more just and sustainable world.
That's the goal.
It's not just about the science.
Right.
It's about the values that guide its application.
Ethics should always be at the forefront.
This deep dive has been truly eye-opening.
It has been a fascinating journey.
We've gone from teleporting information between computers to talking about quantum effects in our own minds.
It's amazing how far we've come in understanding this quantum world.
It's like we've lifted the veil on a hidden reality.
And with each discovery, we uncover even more questions.
Pushing the boundaries of human knowledge.
It's a never-ending quest.
So where do we go from here?
The exploration continues.
What's the next step in our quantum adventure?
Well, let's talk about something that's intrigued physicists and philosophers for ages.
Okay, what's that?
The concept of time.
Time.
Yeah, we've already talked about time crystals.
Right, those things that repeat in time instead of space.
Exactly, but our journey into the nature of time is just beginning.
Okay, I'm ready to dive in.
Great, but before we completely lose ourselves in the quantum realm,
Yeah.
let's take a moment to recap.
Sounds good.
We started with quantum teleportation,
Right, transferring information between quantum computers.
a breakthrough that opens up a world of possibilities.
Secure communication, advanced computing.
It's truly revolutionary.
And we delved into the Orch OR theory.
Exploring the idea that consciousness might come from quantum events happening in those microtubules in our brains.
We discussed the evidence, the arguments for and against it.
And all the exciting research that's going on.
And finally, we looked at that experiment that set a world record for quantum entanglement,
The one with the optical fibers.
bringing us closer to a real quantum internet.
It's mind-blowing to think about what the future holds.
This deep dive has taken us on a whirlwind tour of the quantum realm,
It has.
where science fiction becomes reality.
And the nature of reality itself is questioned.
But before we venture any further down this rabbit hole,
Yeah.
let's pause for a moment
Okay.
to let our minds catch up with all this incredible information.
It's a lot to process.
We'll be back soon for the final part of our quantum adventure.
I can't wait.
Stay tuned.
All right, so before we took that little detour, we were about to jump into the concept of time.
Right, and how it all ties into quantum mechanics.
Yeah, it's one of those things we just sort of accept in our everyday lives.
We take it for granted.
But I have a feeling this is where things get really strange.
You're not wrong.
So how does quantum mechanics change how we think about time? Well, the time we experience, it's linear.
It goes in one direction.
Past, present, future.
Nice and straightforward.
But in the quantum realm, time isn't so simple.
Okay, I'm intrigued.
We already talked about time crystals a bit.
Right, those mind-boggling structures that repeat in time.
Instead of space,
Yeah.
time crystals show us that time at its core. It might not be this rigid, unchanging thing we think it is.
So are you saying time can be flexible?
In a way, yes.
Okay, this is where I need you to break down for me.
One of the big ideas in quantum mechanics is superposition.
Right, where a particle can be in multiple states at once.
Exactly, and this applies to time too.
Wait, hold on.
Yeah,
Are you saying a particle can exist at multiple points in time simultaneously?
that's one way to interpret it.
Whoa.
It suggests that the past, present, and future
Yeah.
might not be so separate after all.
That's a lot to process.
It is.
Are there any experiments that back up this idea of quantum time?
There's this famous thought experiment called Wheeler's delayed choice experiment.
What's that about?
It shows how a measurement we make in the present can seem to affect the past state of a particle.
So you're saying our choices now can change what happened in the past?
It's a mind-bending concept.
It really is.
It challenges our usual understanding of cause and effect.
Right, where the cause always comes before the effect.
Exactly. But in the quantum world,
Yeah.
cause and effect can get all mixed up.
So does this mean the future's already decided?
That's a big question.
Or do we still have free will in this quantum universe?
It's something physicists and philosophers have been debating for ages.
I bet.
Some interpretations of quantum mechanics suggest the future's not fixed.
Okay.
It's more like a bunch of possibilities.
So our choices still matter.
They could, even if time itself isn't as straightforward as we thought.
This whole deep dive into quantum mechanics has been incredible.
It's been a wild ride.
We've gone from teleportation
Quantum computers.
to the mysteries of consciousness.
And now, the nature of time itself.
It's amazing to think how far we've come in understanding this quantum world.
We've only scratched the surface.
There's still so much to learn.
So many mysteries left to unravel.
It's exciting to think about what the future holds.
It is, and the most important thing is to stay curious.
To keep asking questions.
And to never stop exploring.
That's a great note to end on.
It has been a pleasure.
The feeling is mutual. And to all our listeners out there,
Keep those minds open.
keep questioning and keep wondering.
The quantum universe is full of possibilities.
And we can't wait to see what we discover next.